Taking question number 17 of exercise 11.2 of 3-dimensional geometry. The question is, find the shortest distance between the lines whose vector equations are r is equal to 1 minus t into I plus t minus 2 into j plus 3 minus 2t into k, and the second equation is s plus 1 into I plus 2s minus 1 into j minus 2s plus 1 into k. Okay. Now firstly, as you can see that both the equations are not in the standard vector form of the line, that is r is equal to a plus lambda b, but they can be converted. And how they can be converted is by opening the bracket and separating the terms containing t and the terms which are not containing t. For example, if we take the first line, we can write it like this: r is equal to I minus 2j plus 3k plus t times minus I plus j minus 2k. And you can see that this I is obtained because the first bracket contained 1 into I. The second bracket contained minus 2 and minus 2 into j minus 2j. The third bracket contained 3 into k, so I obtained 3k. Okay. And similarly, you can see that minus t when multiplied with I, minus t is going to multiply with j, and minus 2t will multiply with k, and on taking t common I am going to get minus I plus j minus 2k. Okay. And similarly, we are going to do this for the second equation to get the second equation as I minus j minus k plus s times I plus 2j minus 2k. Okay, again you have to simply separate the terms, okay, of which are going to contain s and which are not going to contain s. So we can solve both the equation like this. Now, the shortest distance between the two lines is given by r is equal to a1 plus lambda b1 and r is equal to a2 plus lambda b2. These two are the lines which we have taken. Then the shortest distance between the two lines is given by a2 minus a1 dot b1 cross b2 upon magnitude of b1 cross b2 and whole thing inside the modulus. So to solve this question, as we have done earlier, we are going to solve separately a2 minus a1, b1 cross b2, then its magnitude and then its dot product, and finally we are going to place this value in this formula to calculate the value of d. So first of all, we can write from this equation a1 b1 as I minus 2j plus 3k and b1 as minus I plus j minus 2k, and similarly a2 b2 as this value. So a2 minus a1 is the difference of these two values. This will be equal to I minus j minus k minus I minus 2j plus 3k, or this will be equal to j minus 4k. Okay. Now b1 cross b2 would be equal to ijk, that is the cross product of these two vectors b1 and b2. So for this I write ijk in the first row, the coefficient of ijk for the vector b1 in the second row, and coefficient of ijk for this vector b2 in the third row. And we can simplify this as equal to I into minus 2, and this is going to become plus 4 minus minus plus minus j, this will be equal to 2 minus minus plus 2 k, this will equal to minus 2 minus 1. So this will be equal to 2i minus 4j minus 3k. Okay, so now we have calculated the value of b1 cross b2. Further, the magnitude of b1 cross b2 can be calculated by taking the modulus of 2i minus 4j minus 3k, and this will be equal to square root of 2 square minus 4 square plus minus 3 square, which will be equal to square root of 4 plus 16 plus 9, that will be equal to square root of 29. Now a2 minus a1 dot b1 cross b2 will be equal to the dot product of a2 minus a1, that is j minus 4k, and b1 cross b2, that is this vector. So on taking the cross product, so we have to multiply the coefficient of j with coefficient of j and coefficient of k with coefficient of k. The coefficient of I is not in the first bracket, so we are going to take the coefficient of I as equal to 0. 0 into 2 is 0. or simply it will be equal to minus 4 plus 12, or that will be equal to 8. So the distance between the line on applying this formula would be equal to 8 upon square root of 29. You can see that this value a2 minus a1 dot b1 cross b2 is equal to 8, and the modulus of b1 cross b2 is equal to square root of 29, which is equal to 8 upon square root of 29, which is the required answer. So this is how we are going to solve this question.
Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.